I'm Josh from XZ, and over the next 20 minutes, we're going to change how you think about open source software for everyone. Today, I want you to forget everything you know about free code and community contributions. Instead, I want you to think like a CFO. Think like an accountant, and think about assets, liabilities, cash flow, and risk exposure. Because here's the truth, open source isn't free. It never has been. And every line of code in your system is either making you money or costing you money. The difference is, until now, you couldn't measure which was which. And today you're going to learn the theory behind XZ's AI to quantify the ROI of open source security. You're going to turn invisible risk into visible numbers, and numbers that the board will understand. Numbers that will change how you invest, how you protect, and how you profit from the code that runs your business. We say insecurity must end. And today we will show you just how it has become too expensive to ignore. There we go. December 2021, Log4j hit the world like a digital earthquake. Systems crashed from how frequently they were patched, and teams worked through Christmas. CEOs got phone calls at midnight asking why their billion-dollar infrastructure was being held hostage by a free library. We at XZ were there with Ethereum on the day of Log4j. We saw that problem clearly and firsthand. Open source software was everywhere, and Log4j could be anywhere. 3 human beings were responsible for securing Ethereum's proof of stake transition, a massive $200 million transaction. Every decision felt like it could bring the whole thing down. Open source is the backbone of Ethereum. Advanced cryptography, exchanges, DeFi, infrastructure, it's all open source. But the cracks were obvious. Core dependencies were unmaintained or built by a solo dev. Billions of dollars flowed through systems held together by a handful of volunteers who were trying to sway devs into action. And when Log4j hit, we just started building an AI framework that went through the SBOM to prioritize vulnerabilities by their financial impact. We wanted executives to see which risks mattered most in terms of dollars and cents. We even created an internal bounty system for Ethereum, cutting mean time to remediate by 30%. And the world changed after Log4j. We went from trusting everything to questioning everything. From it's probably fine to we need to know for sure. But here's what didn't change. We still don't have the tools to measure what adopting open source with confidence will actually cost us. Good. Do you remember when we used to say this, right? Open source is free, like free beer, right? Everyone laughed, everyone agreed, easy money, right? Download a few libraries, integrate them, ship it. The cost is $0. The value is priceless and the perfect business model, so we thought. We built entire companies on this idea, entire industries. The modern internet runs on free beer. Your mobile apps, your trading platforms, your customer database is all powered by code that costs nothing to acquire. But yeah, open source isn't free beer. It's more like free puppies. Sure, a puppy is free. It's even adorable, but then it needs food, It needs to go to the vet. It needs training. When it chews up your favorite shoes, your carpet, you have to buy new ones. When it bites your neighbor, you have to pay for the lawsuit. Log4j was our wake-up call. Free code today, but vet bills forever. Maintenance cost definitely doesn't equal zero. Every dependency you add is like adopting a pet. It's cute at first, but it needs care, feeding, attention for years. And some of us have adopted upwards of 5,000 pets. That's an insane number of puppies, right? The difference is puppies don't get targeted by nation-state hackers trying to backdoor your trading systems. That cute little library that you downloaded 3 years ago, it's grown up and it's hungry for attention. Attention that you probably don't have time to give it. This creates the perfect condition for hackers. If you treat open source as a clear investment upfront, your costs drop, compliance gets simpler, and your developer brand gets much stronger. So puppies are great, yes, but only if you're ready to feed them into the loyal dogs that can fight for you when they grow up. Now, look at this image. This is kind of what it feels like. It seems like we are trying to clean up the Pacific garbage patch here. Massive problems, tiny solutions, an overwhelmingly small odds of success. Drowning in trash is exactly what most security teams already feel like today. Swimming in an ocean of dependencies, trying to patch CVEs one by one, while new garbage keeps flowing in faster than they can clean it up. The Pacific garbage patch took decades to create, and it'll take decades to clean up. But here's the difference. We cannot wait decades to secure our software supply chains. When we worked on Ethereum security, we saw this coming clearly. Unmanaged open source really is the Pacific garbage patch. It is massive, messy, it's costly. The garbage is flowing in real time, and the attackers, they're not waiting for us to catch up. Every day we delay is another day of accumulating technical debt and security risk. If you don't invest in cleaning upstream, you'll drown downstream. And downstream, well, that's where you're going to need a bigger boat. The most famous line from Jaws is probably the most relevant line for cybersecurity in 2025. OSS breaches are up 5 times year over year. 5 times, not 50%, not double, 500% growth in attacks targeting the very foundation of our digital infrastructure. The threat has grown exponentially. Your budget and tools stayed linear, and you can't patch the ocean liner with duct tape and hope. So it is time to upgrade from the fishing boat to an AI swarm of drones. Things are more interesting now. The EU Cyber Resilience Act just changed the game for you and me completely. What we're talking about right now isn't a suggestion anymore. It's the law. One unattended maintainer can now lead to a fine of 2.5% of annual turnover. Not profit, turnover. That's board level risk. One maintainer, one open source library, one oversight. Think about that. A single volunteer stopping to work weekends on a library you've never heard of can trigger a fine bigger than most companies' entire security budgets. This creates huge tail risk. There will be all kinds of exploits to this system targeting the financial services industry. The kind of risk that gets CISOs fired. The kind of risk that makes boards ask very uncomfortable questions about what we actually know about our dependencies. And here's the uncomfortable truth. It's your code now. Every open source library you use, every dependency of a dependency, every transitive relationship is 3 layers deep. If you make money from it, you're liable for it. The risk is brutal in its simplicity. Open source risk roughly equals open source lines of code. About 2 critical bugs hide in every 10,000 lines of OSS code. And this is not my opinion. These are statistics from the Linux kernel based on millions of vulnerability reports across thousands of projects. More open code equals more risk. More dependencies equal more attack surface. More complexity equals more places for things to go wrong. The question isn't whether you have vulnerable code. You do, you know that. The question is whether you know where it is and what it costs to fix it. The question is if you keep track and manage your liabilities. Let's go, baby. There we go. Here's the paradox. 80% of your security spending goes to patching internal systems, while 90% of your CVE blast radius is imported from upstream open source. We're spending millions scanning our own code, while the risk is imported from dependencies we don't control, maintained by people we've never met, and funded by hope and good intentions. It's like hiring 20 security guards for your penthouse while opening the door for everybody that calls themselves a volunteer. The threat isn't coming through the windows, it's walking through your lobby and it's grinning. This is risk economics turned upside down. We're securing the wrong layer. We're optimizing for the wrong risk. We're fighting today's war with yesterday's tools and tomorrow's budgets. The great thing about open source security is that investing upstream protects the downstream. It saves cash, builds trust with the open source ecosystem, and the criticality used to be simple. Big systems are critical. Small open source libraries are not. Easy, but size doesn't equal risk anymore. That farmer with the pitchfork, he represents your CISO, trying to figure out your digital infrastructure for the season. It takes one library, one bad day, one retirement announcement, one hostile takeover of a GitHub account. The problem with cyber is that we as defenders have to win every time, while attackers just once. And the result is making headlines as the mother of all breaches. The problem is that most critical piece of your infrastructure might be maintained by someone you couldn't pick out of a lineup. Someone who gets paid nothing, and someone who could walk away tomorrow. Someone who might be compromised tomorrow. And that person, that someone, is not liable nor accountable for your risk. So the evolution of criticality means the smallest things can create the biggest problems. Open source security spending reduces risk, it improves compliance, and builds trust in your developer brands. So have a look at this image. A massive skyscraper of modern infrastructure, balanced on the shoulders of one lone maintainer. And this is not a metaphor, this is reality. all modern digital infrastructure, your banking systems, your trading platforms, your customer databases, they all depend on small libraries maintained by individuals. But the biggest risk isn't just in your biggest systems. It's in the components of that system. The ones you forget about. The ones buried 6 layers deep in your dependency tree. Size doesn't equal risk. Visibility doesn't equal importance. The most dangerous code is often the code you can't see, maintained by people whose names you never knew. When a critical dependency becomes a liability, you have 3 choices. The 3 Fs: fixing, forking, or foregoing. Fixing means contributing back, sending patches, funding maintenance, being part of the solution. The mechanic rolls up his sleeves. While forking means taking ownership, creating your own version, maintaining it yourself. Sure, it's the road less traveled, but sometimes it's the safest path. Foregoing means walking away, finding alternatives, accepting the cost of migration. Sometimes the garbage truck is the right answer, but each choice has costs, each choice has risks, and the key is making the choice consciously based on evidence and data, not hope, and not on a developer's feelings at that moment. This is Neo stopping bullets in the matrix, right? This is what leverage looks like in open source security. One upstream secure project can protect thousands of your downstream applications. One secure open source project can shield an entire ecosystem. One investment can multiply across your entire software supply chain. This is why open source security is fundamentally different from proprietary security. When you fix a proprietary bug, you fix your problem. When you fix an open source bug, you fix everyone's problem. Smart money finds leverage. Smart security investment does the same. Look for the fixes that multiply. Look for the patches that compound. And now we get to the heart of it. The balance sheet lens, the way that we have to look at our code. I want you to start thinking of your services as assets. Services generate value. They create cash flow. They make money. Your repositories, on the other hand, are liabilities. They require maintenance. They require security. They carry risk, and they cost money. Your software's net present value equals benefits minus bugs. Cash inflow minus cash outflow. The same math you use for any other business decision. This isn't revolutionary accounting. This is basic finance applied to something that we've never measured before. The value and risks of open source and measurement is the first step to management. Risk isn't binary, though. It's not safe or dangerous. It's a spectrum, a formula, a dial you can tune. Risk is criticality plus severity. You set the weights, you choose the balance. Customer-facing API with a buffer overflow, high criticality, high severity. Internal dev tool with a minor data leak, low criticality, medium severity. an open source dependency with just 2 maintainers powering thousands of your services. Low severity. Ginormous criticality. Tune your dials, aim your spend, and stop chasing CVSS metrics without context and treating all risks as equal when they clearly are not. Value at risk. Every trader knows this formula. Every risk manager lives by it, and now we apply it to code. VAR broadly is the probability distribution of risk to your assets. Your job as an open source professional is to help your board see clear loss from doing nothing. Not theoretical risk and narratives, not maybe problems, Excel sheets, discounted cash flows, downside exposure. When you put a price tag on an action, action becomes the obvious choice. And you don't need perfect math. You need shovel-ready wins. Quick victories that prove the model works. That's what good security investment looks like. Your job is to find a 10-line patch in an open source dependency that is used everywhere. It's a 2-day effort with a VAR reduction of millions of dollars. You will find open source patches with ROI that make marketing campaigns jealous. And I know I'm from marketing. And develop that into a lighthouse project of cultural transformation when it comes to cyber risk. These wins exist in your code base right now. Small open source patches with massive impact, low effort, and high reward. Here's the secret sauce. Use AI to do the heavy lifting. Plug all of your repositories into an AI system that can estimate dollar risk, dollar VAR, dollar fixes, and dollar ROI. Let machines do what machines do best. Process massive amounts of data and find patterns humans miss. AI doesn't replace human judgment, it amplifies it. It turns the gut instincts of your developers into a data-driven decision maker. It scales analysis from hundreds of repositories to millions of dependencies. And the future of security isn't more analysts, it's better analysis. This is the most important lesson, the one written on the chalkboard that everyone needs to remember. It's all your problem now. Every dependency, every transitive relationship, every maintainer who might quit tomorrow. The days of not our code, not our problem are over. If it's in your software supply chain, it's your liability. If it's in your dependency tree, it's your risk. And ownership isn't just about the code that you write, it's about the code that you choose. The libraries you trust and the maintainers you depend on. But looking ahead, the path forward isn't complicated. Measure what matters, price what's risky. Invest where it counts. Repeat, repeat, repeat the process. Turn invisible dependencies into visible open source assets. Turn unmeasured risk into quantified investment opportunities, and turn security spending into a business strategy. The destination is clear: a world where open source security is as measurable, manageable, and profitable as any other business function. In the process, you will build relationships with open source maintainers and the ecosystem that will have compounding effects for decades to come. Got it. And so here's our call to action. Start now, start small, But start somewhere. You don't have to solve the entire Pacific garbage patch today, but you can clean one beach at a time. You can find and secure one critical dependency, and you can measure one piece of your supply chain. Every journey starts with a single step. Every cleanup starts with picking up one piece of trash. And every security software supply chain starts with understanding one critical component. Start today. Your turn. Thank you. Questions?
I have a question, actually. So the log4j thing, everybody remembers that. Do you have any idea, on like a guesstimate, how many companies were impacted? And how long did it maybe on average take for each of these companies to sort out one places down?
So the question was, how many companies were affected by log4j, and how long it took to clean up that specific beach?
Yeah.
The first question is what we call in security an unknown unknown. So nobody knows, because a lot of companies don't have great incentives to report. Hey, we have been affected by log4j, and there's estimates on how much it costs from the vendor side, where you bring in the Tiger teams and the fire hires to still fix log4j, and that's supposed to cost $1 billion per year still. So like in last year's numbers.
Any other questions? All right. Yes.
What's XO driving to do? Obviously, I've certainly spoken to Tobias previously on various special interest groups. What are you sort of bringing to the table? Obviously, you've got the experience with Ethereum. What's your intent or plan, desired outcome from sort of getting us to focus on this?
Yeah, so XOR is an agentic AI solution that does many steps for you and basically identifies the gaps in the open source code and offers suggestions to fill them. So it's
you can think about it as there's a different variant on what point in time. So what we do today is patch CVEs really fast. That means in open source projects that you're using, where you can deploy an agent that goes ahead and patches, review the patches, make sure they're really good, but also in internal architecture. This mean time to remediate is the metric that we're obsessing on. When it comes to what XOR is supposed or will do in the future, you can think about it, okay, you have your Artifactory, you consume your open source, you run some checks, you have some static analyzers to tell, okay, everything is fine. That's not continuous. So instead of just consuming it once, checking it once, you have a firewall that continuously looks at the open source that you're using in real time. And when we find something in there, we contribute it back. So that means you have batteries included, open source with compliance, provenance, and patch CVEs. That's what the enterprise gets. What the open source ecosystem gets is the patches, where we really speed up issue triage, pull request review, patching of vulnerabilities, and give that back to the community.
And I guess what FINOS can add there is you don't see all of the consumption, because once we've taken an open source library into our ecosystem models, you don't know how many times we're using that. So I guess if FINOS could get us to publish anonymous with the amount we're using, that helps drive the prioritization.
Right.
all right. Last chance. Going once.
Any questions on the economic side of things? That's probably the most fascinating part of open source.
Wrong technologist, someone else pays it.
You don't like economics? It's just too boring. The math is too simple.
It's too hard.
Fair enough.
Okay.
All right. Thank you very much.
Thank you.